Hey, Carly.
Hey, Wade.
Today we're going to talk about my favorite rule in all of data science.
What is that?
That is the law of large numbers. So the law of large numbers is this really powerful law that's going to always be true. And it involves how we do simulations and sampling data. So if we take more and more simulations, the law of large numbers tells us that the more simulations we do, or the more samples that we take of the data, the average result is going to tend towards the expected value. So Carly, expected value is something that you work with a lot.
Yeah, so expected value is a concept in statistics that comes up especially with simulations. And it tells us if you do something over and over again, what are you expected to get? Or in other words, which result has the highest probability?
So the law of large numbers says that as the number of samples goes up, then the result should be the average will tend towards the expected value. So we should get closer and closer to the expected value the more and more samples we do.
Yes,
so
exactly.
We can look at a lot of different ways of looking at this, but I'm going to look at just the simplest way so that we can write a little bit of code, because I hate just taking laws as facts. I want to actually prove that it's true. And we have Python to prove that it's true. So if we're going to have to find the average, and I think we're going to look at dice. So in fact, let's not just look at one die, let's look at two die. So I'm going to grab two pink dice. And if I roll these two dice and I add them together, I'm going to get what I'm going to call the sum, or the result. So the result of two die roll, I got a 6 right here. So what is the expected value, Carly?
So the expected value when you roll two dice is actually 7. Because if we think about all the possibilities, if we think about the sample space of rolling two dice, there are 36 possibilities. And if we count up the one that's the most probable, we get 7.
Okay, so if the expected outcome is we roll a bunch of times, so Carly, you just roll, or I just rolled here again, I got another 6. So I got a 10, I got a 2, and we see that none of these are a 7 yet. Is that weird?
Not yet, because we only rolled 4 times. Really, if we did this 1,000 times, we should see that the most common outcome is a 7. And that's what we expect, but it's not always going to be the case.
And the law of large numbers tells us as we increase the number of samples, our result should tend towards the expected value, the average of our results. So I'm going to write a really, really simple Python program without even using data frames to just randomly generate it. So to find the average, I'm going to need a sum. So I'm going to say the sum is initially 0, and I'm going to roll dice and basically add to the sum. So I'm going to initially start with just 10 dice rolls. So for I in range 10 is going to roll dice 10 times, and I'm going to simply add to the sum 2 different dice rolls. So I'm going to say sum is equal to the old value of sum plus random.randInt 1, 6. And then I'm going to basically repeat this line again and say sum is equal to sum plus random.randInt 1, 6. And what I've done here is I've basically rolled 2 different dice, and I'm keeping track of the sum of these dice. And it's similar to what I'm doing over here. I rolled 2 dice, I got a 6. So this was, I think, a 2 and a 4. And then this was a 3 and a 3. So I've got a 6. You can get 6 multiple different ways. I'm pretty sure this was a 5 and a 5. So we're simply adding this all together. A 2 was definitely a 1 and a 1. So.
And you're using Python to simulate this real event of rolling the 2 dice.
And the sum is basically going to be a cumulative sum. So here, my sum value would have been 12, because that's 6 plus 6, then 22, 24, for example. And then to get an average, if I have 10 different dice rolls, how would I find the average of a sum?
So basically, to find the average of the sum, you're just going to divide by 10.
So I'm going to simply say average is equal to sum divided by 10. And now I'm going to just write at the very bottom, I'm just going to write average as the variable, and that's going to tell Python to print out the value of average. So if I do 10 dice roll of 2 dice and find the average, do you have that written up, Carly?
6.9.
So we have the average result of 10 rolls is 6.9. And let's run that a couple of different times because we're doing simulations, so we're not getting the exact result. And we're going to see kind of what is the range of values that we might get.
5.7, 7.7, 6.4,
6.4. Awesome.
7.3.
Awesome. So that was 5 different samples. So that was with 10. And the law of large numbers says we should tend towards the expected value if we have more samples. So I think we should just do a lot more samples. And instead of 10, let's make that 1,000. And make sure to make 1,000 in the 4i in range. And we want to divide by 1,000 here on the average.
Good call. 6.999.
6.999.
6.969.
969.
6.909.
6.909.
Yep. 6.984.
984. And one last one to get another 5 samples.
7.011.
7.011. So now let's look at a little bit of analysis here. So we have, when we only had 10 dice rolls, we were kind of close to expected value because Carly, what did you say the expected value was?
7.
So expected value is 7. So we saw we were close to 7 here. We were pretty far off here. It's kind of 0.7 off here, 0.6 off here, 0.3 off here. So we were like maybe about half to 1 off.
Yeah.
But here, 0.999?
We're extremely close to 7 for all of them.
Wow. So here we were off by only 0.001. Here we were off by 0.031. Here we're off by 0.09. Here we're off by only 0.016. Here we're off by only 0.011. So we were off by like 0.01.
So we're basically seeing the law of large numbers in action. The more times we do this, the less we're going to be off. Or in other words, the closer the average is going to be to that expected value. And we're going to look at exactly how to calculate expected values later in this series. But one thing, Wade, too, that I always like to think about is with coins. So I feel like the law of large numbers is seen there. If we flip a coin 5 times, and we could simulate this in Python, if we flip a coin 10 times, then if we simulate that in Python, it wouldn't be weird to get maybe 3 heads or 8 heads. We're expected to get 5 heads, but with just 10 times, you could get however many heads. But if we flipped a coin 1,000,000 times, we should get really, really, really close to 500,000 heads.
And this is exactly the logic that I know casinos use to make money. Because the first time you deal a deck of cards, the player may get really, really lucky. You might win a lot of money in blackjack. But over 1,000,000 samples, 1,000,000 people playing cards, the casino knows the law of large numbers tells them that the average payout is going to tend towards the expected value. And as long as the expected value is in the casino's favor, it's basically like they're printing free money.
Exactly. Usually with most gambling games, maybe all gambling games, the expected value is negative, so you're expected to lose.
Or as the casino owner, I'm expected to win.
Yes.